Hello. In this video, we're going to continue with letter M. M here says y equals natural log of 2x to the fourth minus 3x. Now, again, because we're working with natural log, I don't need to deal with anything else. We won't have a natural log in our answer. But with this natural log, we just need to go ahead and find the derivative. So we have dy dx here is equal to the derivative of any logarithm is a quotient. In the numerator, it's the derivative of the argument. So that's 8x cubed. And then negative 3x becomes minus 3. So it's 8x cubed minus 3 in the numerator. In the denominator, you just rewrite whatever that is. In this case, it is 2x to the fourth minus 3x. And because this, again, this is a natural log, I don't need a natural log in my answer here. And that's it. Now, even if I factored the denominator here, I'd be left with x times 2x cubed minus 3, and that's not 8x cubed minus 3. So there's not a common factor. So that's as far as we can go. And there we go. That's M. Next, let's look at N. Y equals negative 3x times the natural log of 4x plus 3. Well, notice that here we have negative 3x. So this is a product, this is a function of x times another function of x. And that forces us to use the product rule in this situation. So this means that dy dx here is equal to the first one, negative 3x, times the derivative of the second. So multiply by, in this case, we're going to have a quotient here. The derivative of the argument is 4, and the argument is 4x plus 3, and that's the quotient. And because this is a natural log, I don't need a natural log down here. And then plus, because we have the product rule here, the second, the natural log of 4x plus 3, times the derivative of the first, which is minus 3. Good. Now, notice that this negative 3x over here is actually negative 3x over 1. So I can go ahead and multiply those together, and I'm just going to bring the negative 3 out front, and then that's as far as I'm going to go. That gives me negative 12x divided by 4x plus 3. And then bring the negative 3 out front makes that a minus 3 times the natural log of 4x plus 3. And there we go. That is dy dx here. Letter O, we have y equals parentheses, natural log of x plus 5, close parentheses, to the 8th power. This one is written in the form that you want to use the chain rule with. Now, the chain rule here says we actually use the power rule first, because that's the outer function. So bring the 8 down. That gives me 8. And then just rewrite the argument, rewrite the base here, which is the natural log of x plus 5. And then subtract 1 from the exponent gives me 7. Good. But then I take the derivative of the base here. And so since it's a logarithm, it's going to give me a quotient. The numerator is the derivative of the argument of the logarithm. So the derivative of x plus 5 is 1, because that's the number in front of x there. And then in the denominator, just rewrite the x plus 5. And again, because it's a natural log, I don't need a natural log in my answer. Fantastic. Now think of this as over 1 and then multiply straight across. So really all you're left with here is 8 parentheses, natural log of x plus 5, close parentheses, to the 7th power, and then all over x plus 5. And that is the derivative. Now notice that the x plus 5, the x plus 5 and this x plus 5, they don't divide each other. The reason they don't, because this x plus 5 is the argument of a logarithm. So this is the entire factor here, the natural log of x plus 5. There's not another natural log of x plus 5 down here. So therefore, these two cannot cancel each other. Alrighty. Well, there you go. Here are the last three parts for question 1. In the next video, I will continue with question 2. Have fun.